What's up, everybody? This is me, Yawar Manzoor, and I believe everybody is doing great, nice, and absolutely fine. So I just want to know in the live chat if you can hear me and if you can see me properly. All of you in the live chat. And welcome to JEE English Unacademy. And if you haven't subscribed yet, subscribe it right away, okay? And hit that bell notification button because we'll be getting the update every single time whenever we come live. And in this lecture today, we will be talking about the capacitors. Okay, what are actually these capacitors? Why do we study these capacitors? Okay, combination of capacitors, energy stored in capacitors. Understand, if for example there are different number of capacitors connected in series, how we can find the equivalent capacitance, how we can find the individual voltages, everything we'll be talking about in the today's session itself. So I want everybody of you to tell me in the live chat if you can hear me and properly in the live chat itself, all of you. Okay, that's great. So yeah, good evening. And basically this is the first lecture of capacitors, and next we have the capacitors lecture number 2. Okay, when we are done, once we get done with that, we are done with the capacitors. Okay, and ladies and gentlemen, boys and girls, my name is Yawar Manzoor and I'm from Kashmir. Exactly, I'm a JEE Physics expert, and this is the Fury Live. We run this series Fury Live for JEE 2023, JEE 2022 people. Understand? So this is completely for you people only. So now, if you want to follow me, you can definitely follow me on Unacademy. This is my username over there, understand, on Unacademy, because we come up with so many special classes every single time. That's completely for free. You can definitely enroll in our special classes. So for that, you have to follow me. And apart from this YouTube platform, we basically teach on Unacademy's own platform. There, if you want to learn from us, or if you want to learn from the country's top educators, because country's top educators are teaching you over there, even quota's top educators are teaching you inside Unacademy. So for that, you have to take this plus subscription, or you have to take this iconic subscription. Understand? Because in this plus subscription, you'll be getting so many benefits like live classes, weekly tests, structured courses, unlimited access. Unlimited access means in a particular category, you can watch anybody's lecture. Hi, what's up? What's going on? And in this iconic subscription, you will be getting what? All the benefits you get in plus, and there are some extra benefits as well. That's why we call this as iconic subscription, golden subscription. Okay, that's personal guidance, test analysis, experts guidelines, study material, study planners. Personal guidance is an educator will help you throughout your exam. If you have any sort of doubt, can definitely ask him. He'll be guiding you. The test analysis will be done from our end only. Understand, our educators will analyze your test scores and everything. Okay, yeah, what's up? And this is the scholarship test. I suggest you people to go for this one completely for free. And if you get the rank under 1000, you'll be getting 100% scholarship. So this is very much necessary for you people if you want to learn free on Unacademy's plus platform. So definitely you should go for this one. I suggest you. Okay, so it will ask you for a code over there. So I suggest you to basically use this code. Okay, YAWAR. Okay, this is my code. It will ask for a code when you basically enroll in that. And there will be 90 questions, 180 minutes, JEE main pattern. Everything will be over there only. And these are the batches which we have launched recently. And in these batches, particularly this batch is completely for the people who want to learn in English language only. So I suggest you, if you want to boost your rank in your upcoming JEE 2022, you should definitely go for the Shine 2.0. And it hasn't started yet. It will start from 15th of September onwards. Okay, 5 days left. So I suggest you to go for this one as soon as possible. Fine. And ladies and gentlemen, you can take this plus subscription for 3 months, 6 months, 12 months, 18 months, and 24 months. If you take this subscription for 3 months, you'll be getting it for something like 17,500. And if you use my code, you'll be getting it only for 14,000. Okay, that is you gonna be getting by using my code. Okay, everybody doing great in the live chat? Do let me know. 1 second, I just need to check my internet connection. I guess this is Is everything clear now? Sorry, this happened. Okay. Okay. So ladies and gentlemen, let me just tell you this once again over here. That is this. You can take this Iconic subscription plus subscription, and we have this beautiful feature on Unacademy that's Ask a Doubt. Everybody, yeah, it's fine now. Okay. Sorry, actually, it was some internet issue. It was some OBS issue, actually. Okay, the software issue. Now it's fine. Okay, I just want to know in the live chat now if you can hear me. Can you just hear me and see me properly? Is it lagging or any sort of issue in the live chat itself? Come on. Okay, so this beautiful feature, Ask a Doubt, you can ask unlimited number of doubts. Ask the doubt anytime. You will get the video solutions, that too in English language and as well as in Hindi language as well. There is a how you can exactly ask this doubt. This doubts and solution feature is on Unacademy's Plus platform. You can click on that. You need to select the picture from your gallery itself, and that picture should be completely clear, not blurred. And you need to crop that particular doubt. You will get the solution within no time for sure. These are the things that you need to keep in your mind while you ask the doubt. And ladies and gentlemen, most importantly, now we need to talk about these capacitors. What actually these capacitors are. Okay, why do we study these capacitors? Understand? And what is the meaning of these capacitors? I'll just give you this simple example that you use in your real life. If, for example, I have a fan over here, okay? I want to start that fan. What am I supposed to do? I'll switch it on and it will start basically working. So what happens over here, whenever we start any electrical device, if it is a fan, motor, or it's a television, whatever it is. So initially, while starting, it needs very large amount of electrical energy. Understand? So it is not possible you can directly start the fan by connecting the wire to that fan and you'll basically plug it on, switch it on, and you can directly supply that large amount of energy to that fan. No. So basically we have to use a device. For example, this is a fan over here. This is a fan over here. I'll just try to create this fan. There's a fan over here. So we'll attach a device to it over here. That very small device. Okay, it's very small in size. So we'll just attach a device to it over here. So what this device exactly does, it stores the electrical energy. It stores a large amount of electrical energy and supplies that electrical energy at once to this fan when we switch it on, when it has to basically start. Because in the initial step, whenever we have to basically run any electrical device, it needs large amount of energy. So it is not possible we can directly send that energy to that electrical device without a device. That is what we call the capacitor. Understand? So this capacitor is a device which is used in order to basically start any electrical device like fan, motor, television, understand, while starting, because it sends large amount of electrical energy at once initially. That's why we say, okay, everybody is able to understand this, whatever I am trying to say, all of you in the live chat itself. Okay, that's great. Fine. So this is the device. So why do we use these capacitors? In order to send large amount of energy, electrical energy initially, in order to start any device like electric fan, motor, or television, whatever it is. Okay, fine. So these are the capacitors. These are very small devices. You might have seen, you can search it on Google, how does it actually looks like. So very small device, attach it to these electrical devices. Fine. Now let's move on to this capacitance. Okay, now we got to understand what is this capacitor. It stores basically what? Electrical energy, and then sends that electrical energy to any electrical device while it has to basically start working. So that is the point over here. Understand? So now the point over here is, next point is, what is this capacitance all about? This capacitance in simple words is nothing but it is what? Capacity to store electrical energy. Now see, what is this capacity to store electrical energy? If I say, for example, I have a capacitor over here. I have the another capacitor over here. This is one, this is capacitor A, capacitor B. This capacitor is able to store, for example, X joules of energy. This capacitor is able to store 10X joules of energy. So, which capacitor has more capacity to store energy? For example, if I say this is the capacitor 1, it can store X joules of energy. This capacitor can store 10X joules of energy. Understand? Electrical energy. So, can I say that this is having more capacity, this is having more ability to store this electrical energy as compared to this one? So I can definitely say this is having more capacitance, this is having more capacitance, this is having less capacitance, because this can store more amount of energy as compared to this one. That's why capacity to store the electrical energy, ability to store the electrical energy, I'll just tell you, I'll just make you understand what exactly this is, how you can exactly store this electrical energy on this capacitor. Now you will say, sir, how can you define this capacitance mathematically, and how can we exactly store the electrical energy in this capacitor? Previously, when we were discussing, everything is clear? Previously, when we were discussing this concept, like in case of potential previously, okay, how do we exactly define the potential energy over there? I have created the one-shot video on that one. I suggest you to go check that out and watch that. Now, I told you, for example, previously I told you there is a charge over here. I'm recalling the things which I have told you before, okay? Electric potential, one shot, Yawar Manzoor, JEE English Unacademy, search that and then come. So if I have, for example, the charge over here, and if I'm bringing another charge which is exactly at infinity. So when I'm bringing it nearer to this charge, for example, I'm bringing it from infinity, and when I'm bringing it nearer to this charge, so basically this is positive, this is positive, this is repelling this charge in outward direction. So means this is applying the electrostatic force on this one in outward direction, push-based force, repulsive force, because both are positive. Now, in order to bring this charge nearer to this one, we have to apply the external force in this case. Understand? That external force I told you previously, it should be slightly greater than this one, so that I'll tell you. So basically we have to apply the external force in this case in order to bring this charge nearer to this one. Now we are using our own efforts, we are using our own external force in order to bring this charge nearer to this one. Means our efforts, our energy should be stored somewhere. So that energy is stored in the form of potential energy. So then I can say this F external, my energy is stored in the form of electrical energy in that case. So I told you previously that at this point, if you want to define the potential exactly, you can exactly define the potential as well. That is at this point, how can you define the potential? Potential energy per unit charge. If you have any sort of confusion, then go watch that, okay? So basically, simple words. So my energy is stored as electrical energy, my energy is stored as potential energy in this case, because this F external I am using in that case, fine? So this was the scene over there. Now listen to me very carefully. I'm just trying to make you understand this fact, how we can define this capacitance mathematically, okay? That is the point. Everybody able to understand? Come on in the live chat, all of you. Now listen to me. For example, if I say there is a capacitor over here, okay, whatever the capacitor is, okay, there is a conductor, we call it capacitor, okay. Now what we are exactly saying, that I took a charge, very small charge, that is Q, dq, whatever it is, I stored on this one. Now when I'm storing the next charge, I'm bringing the next charge close to this one. So when I'm taking it closer to this charge, when I'm basically when I wanted to basically store this charge on this spherical capacitor, so there is already charge present on that one, that will repel this in outward direction, You will say, sir, yes, means at this point this is repelling this in outward direction. Can you tell me how much potential will be exactly over here? You will say, sir, potential will be at this point. Previously we have defined at this point, if this is a charge, because of this charge at this point r distance, potential is nothing but kq by r, previously discussed, okay? Now potential is what? Amount of work done in bringing the unit charge from this point to this point. Forget about this definition. Potential is basically at this point, this is repelling, how much repulsion this charge is creating, how much repulsion this capacitor is creating in the outward direction on this one. Now if I say more, instead of q, there is a 2q placed on this one. You will say, sir, 2q charge will create more repulsion. Means because of that 2q charge, there will be more potential over here, because k 2q by r, k 3q by r. So it will create more potential at this point, more repulsion at this point. So we'll have to do more work done in order to bring this charge and store it on this one. Everybody able to understand this one? So what I'm trying to say exactly over here is, listen to me very carefully. What I'm exactly trying to make you understand is, so when I'm bringing this charge and storing on this one, the more I store the charge on this capacitor, the more potential is basically being generated. Understand? The more potential is over there. So means if there is charge 2q, it will create more repulsion when I'm bringing third charge nearer to this one, storing on this one. Why? Because this charge will create more repulsion. I'll have to do more work done. So there will be more potential over here because of this charge. Understand? So in that case, I'll have to use more external force in order to store this charge. So what I am saying that this, whatever I am trying to basically store the charge on this one, that will be directly proportional to this potential. More the charge, more will be potential. More the charge, more will be potential. Is it clear? More the charge, more will be potential. Now, if I say, for example, over here, very simple case, that is, I am saying that charge more on this one, at this point potential will be more, repulsion will be more, I'll have to do more work. If I say you that replace this with this proportionality with some constant, you will say this is nothing but CV in this case. Understand? So this is Q is equal to CV in this case, where this C is nothing but capacitance. Okay? This is how we actually find the capacitance. Understand? From this also, you can define this capacitance. Understand? So this C is what? This C is nothing but how much capacity does it have to store this much of charge. So if we are storing 1 coulomb of charge, if we are the potential will be how much? The potential will be, for example, 1 volts. In that case, this capacitance will be what? It will be 1 farad. Understand? So simply you just remember one thing. I'm just finding the mathematical formula for this one. Forget about that. Whatever I'm trying to say, that is, I am basically saying how much ability, how much capacity does this capacitor have in order to store the charge. If I say this have X capacity, means that much is its capacitance exactly. So from this, can we say this capacitance is nothing but Q by V? Yes, definitely. Understand? Everybody? You got it? Okay. So what? Now you will have questions in your mind. Sir, does this capacitance depends upon the charge, or does this capacitance depends upon the potential? No, it doesn't depend upon the charge. Whatever the charge you will store over here, capacitance will not change. That will remain constant. Because the capacitance is constant. It's a constant of proportionality. Capacitance depends upon the properties of a material. Different materials will have different capacitance. Understand? So that's why. So how much, whatever the charge you will store on this one, it will not affect its capacitance, but it will affect its potential. Potential will change because more charge you will store, more potential will be created, more work we need to do in order to store that charge. Fine. So that's why this capacitance doesn't depend upon this charge or this potential, because this is a constant. This is constant. So it doesn't depend upon this thing and this thing. It depends upon some other factors. I'll tell you after some time. Understand? So this is basically the concept of capacitance, how we exactly define it. It is a constant of proportionality. Capacitance for different materials will be different. Like for this material, if I say capacitance is X, okay, X, it can store X amount of electrical energy. So that means if you increase the charge, that will increase the potential. So we need to do more work done in order to store more charge, but we can still store that amount of charge only. See how I will explain basically this to you. If I say, listen to me, if I say, for example, I have this capacitor over here. Now, we place the charge Q first, then place 2Q, then 3Q. So now, we can store, for example, 10Q of charge. If we, in terms of Q only, we'll define. So we can store 10Q of charge on this one. So what I'm trying to say over here is, so when we basically stored 5Q, now it will start more repulsion. At this point, potential will be more, it will start more repulsion. Now what happens over here is, will have to do more work done in bringing more charge, sixth charge. If this is the sixth charge, we'll have to do more work done, more external force, but we can still store 10Q in this one because capacitance remains same. That depends upon the material. I know it will be difficult for us to store over there, yes, but it is what? It is what? We can still store 10Q, but will be difficult now. If I say, for example, see, have you studied this relation? If I, for example, bring this charge from infinity to some other point, how much will be the potential difference or potential? You will simply say, sir, this VA minus VB is nothing but work done by external force in bringing that charge, that Q naught, whichever you are bringing. This is the potential difference. Can we just write it? Nothing but that is delta V is nothing but this. If we are bringing small charge, that is dW, and this is dQ. Understand? We'll do the small work done in bringing this charge from this point. So what exactly I'm getting, if for example this potential difference is coming out to be V, dW is nothing but V dQ exactly. So on increasing the potential, I'll have to do more work done. So this is the final formula. I have discussed this previously, okay, when we are discussing the potential and all. So now on increasing the potential, more work I need to do in order to store that charge on this one, but capacitance remains same. Understand? Increasing this one, more potential, more work done I need to do. Understand? This is the concept, bro. Now see. Yes. Everything is clear. Come on, in the live chat, I just need to know if everything is clear. Yeah, it has to be crystal clear. Now see, we say this capacitance depends upon the shape, size of the conductor. Understand? If the conductor is having large shape, it depends upon that. Dimensions of the conductor. Shape, size. It doesn't depend upon the charge stored on the capacitor. Potential. This depends upon the surrounding medium, what medium we are basically placing that. I'll give you the proof after some time. Doesn't depend upon the charge on the capacitor. Potential on the conductor, that conductor, capacitor, whatever you say. Potential energy, this. It is represented, we represent this capacitor, something like this, okay? Clear? That's great. When you learn from me, there will be no confusion in your mind. But you have to make sure that you will keep your mind here only. You'll just look at me and try to understand the things, because I make it very simple. Understand? Because I try to analyze the things, what point can make the confusion in students' mind. Understand? I think it like that way. That's why people understand my points very clearly. Okay. Okay, it's gonna be okay. Types of a conductor. Not conductor, capacitor. Understand? There are different types of capacitors. First of all, we say spherical capacitor. This is a spherical capacitor of R radius. Now, initially this is uncharged. How we can charge it? We need to basically bring this charge Q, very small charge or whatever it is. We need to take this charge and place it on this. Means some external agent has to do it. Means a battery. If I'm a battery, I have to do it. I have to bring it from somewhere and I have to place it on this one. Next one, when I am placing that, it will start repulsion, electrostatic repulsion over here. Understand? Over here, because already charge is present on this one. That charge will repel the next charge if I want to store the more charge. So I have to use the external force, means I have to do the external work done. That work done will be stored as the energy over here. That work done will basically store the charge on this one. Understand? So that is what we say. This is a spherical capacitor, on spherical in shape, R in the radius. Now if I ask you, what is the capacitance of this spherical capacitor? What will be the capacity of this to store the electrical energy? How much exactly will that be? You will say, sir, it is very simple. We can easily find it. So you'll say, sir, this C is nothing but that is Q by V. We can find it by using this formula. It is very simple. Okay, I'm saying, okay, find it. Tell me how much it is. Then we'll say charge Q. For example, we stored the charge Q on this one. Fine, we stored the charge Q. How much is the potential created? We need to find this potential. How we can find the potential? I have told you previously, if this is a charge Q, at r distance, how much is potential? That is kq by r. Previously explained this in when we are studying the electrostatic potential. In that case, at r distance, how much is electrostatic potential? That is kq by r. At r distance, how much is electric field? You will say, sir, this electric field will be nothing but that is kq by r square. Both are the functions of r. kq is constant, means if you want to define the electric field at a point, either you can define it by potential or electric field intensity. It will create confusion. It will create confusion. For this, you have to watch my previous lectures. Okay, so we know. So at r distance, how much will be the potential? You will simply say, sir, that is nothing but this k, this q. If charge q is over there, charge q upon what is the radius? That is nothing but r. So we got the potential. Put it over here. So c is nothing but this q by this kq by this r. This will cancel. So it will be r by k exactly. So c will be nothing but what is the value of k? 1 by 4 pi epsilon naught. So this r upon 1 by 4 pi this epsilon naught. So it will go up. So it will be nothing but, I'll just write c is nothing but it will be 4 pi epsilon naught this r exactly. Now you tell me one thing. You tell me one thing. I'll tell you everything. Let's basically get into that polar plate capacitors, okay? I'll tell you everything. There will be no confusion, okay? I will tell you how exactly potential is increased between these capacitors. How do we exactly do that? I'll tell you everything. For that, that's why I keep saying this every single time. You should know what this potential is exactly. What is the potential difference? That's why I suggest you to go check my previous videos. That will give you the clear feel. Still, I'll explain you. Don't worry about that. So in this case, we got the capacitance of this capacitor. How much it came out to be? That is 4 pi epsilon naught r. Does this capacitance depend upon the charge placed on the capacitor or the potential? Definitely not. It depends upon r. Radius means size of this capacitor. Understand? Size. The more size it have, the more will be capacitance. It depends upon the medium epsilon naught. What is this? Permittivity. Previously electrostatics. Okay. This. So that's why I keep saying you, it doesn't depend upon the charge present on this one. It doesn't depend. But on increasing the charge, potential will increase. But on increasing the charge, capacitance remains same, because that is the property of this material. How much it can, how much ability does it have to store the charge? And if you increase the charge, we have to do more work than in storing more charge, but we can still store that amount of charge, whatever the capacity that capacitor have. That is this one. Come on, moving on to the next one. We have polar plate capacitors right now. What are these polar plates? See, these have the disadvantages. Over here, if we store the electrical energy in the form of electric field or electric charge, whatever you say, so that is not bound over here. It can lose it anytime. So that's why these are having the disadvantages. This is a polar plate capacitors. How this polar plate capacitor exactly looks like? This is basically a plate over here. This is basically a plate over here. There is another plate over here. The size of these capacitors, it can be of the circular in shape, it can be of this square, rectangle in shape, rectangular, whatever it is. So size is basically equal, and this distance between these two should be very small. Understand? In comparison to size of these, I'll tell you after some time why it has to be very small. I'll tell you. So I'm saying that this is the shape of a polar plate capacitor. One plate, another plate. Understand? One plate, another plate. Distance between these two is, for example, d, very, very, very small in comparison to the size of these plates. Fine. These are metallic plates exactly. Fine. Now, what I am trying to say over here is, initially, this is uncharged. There is no charge on this capacitor initially. There is no charge on this capacitor initially. So what I'm saying exactly supposed to do is that I'll charge this capacitor. I'll create the potential difference exactly. That was your question. I'll tell you over here the answer. So I'll basically charge this capacitor. How I can charge this capacitor? How am I supposed to do that? Previously, what I was doing, for example, this is a charge over here. If I want to bring any of the charge from infinity nearer to this one, so in that case, what am I supposed to do? This will repel this charge in the outward direction, F electrostatic. In order to bring nearer to this one, or if this is a conductor, I have to place it on this one. I have to use what? I have to use external force in bringing this. That external force will basically be stored as the energy over here. So over here, in this case, I was the external agent. But right now, in this case, external agent will be battery. Okay, I'll just connect the battery over here. This battery will do the external work done. Understand? This battery will exactly do the external work done in this case. This battery will exactly do the external work done like in the previous case I was doing in bringing this charge, storing on this one. Now, right now, we'll basically tell the battery, you do this stuff. I don't have to do anything. So what exactly, this is a positive. We represent the battery like this. Positive terminal, negative terminal. Okay. So this is. Now, if I say this battery, what this battery will exactly do? See. Listen to this very carefully. This battery will exactly do, it will take, this is the first plate. There is basically no charge present on this one. This is uncharged right now. Okay. So what this battery will exactly do, it will extract, battery not supplies the charge from itself. Understand? It extracts it from one end and will supply it to the other plate. That is the work of the battery. Understand? It basically only does the work done. Now see, what will battery exactly do over here? It will take the electrons from this one, negative charge electrons from this one, and it will shift it, place it on this one. Or either you can understand it like this way also. It will take the positive charge, small dq charge from this one and place it on this one. Either you understand it like that, or you understand it like it will take the electrons, it will grab the electrons from this one and place it on this one. So when it take the electrons from this one and place it on this one, can we say on this one there will be negative charge? Negative charge will basically occupy. Initially, it started basically what? It started storing the very less amount of charge on this plate. So can I say on this plate, finally after some time, charge minus Q will be present. So on this plate, charge plus Q will be present. Now from the outside, if you look, what is the net charge? You will say 0. But from the inside, this capacitor is basically charged with the charge what? Q charge is present right now on this one. So how did it exactly happen? Because of the battery. Understand? You getting me? Now you tell me one thing. I'll explain the fact. Now, okay, whatever electron concept or dq charge, you can understand it like that one also. Dq charge, you take it from this one and place it on this one. Either you understand it like that, or you understand it whatever is convenient for you, take that one. Now see, I'll give you the answer of your question. Now see, I'm saying that the positive charge is basically now placed on this plate. Okay, positive charge is now occupied on this plate. Negative charge is occupied on this plate. Positive charge, negative charge. Will there be electric field between this? So means electric field will set up. Electric field will set up from positive to negative, Now, if I tell you this distance between the two plates should be very small, in that case, this electric field will be constant. Because for a very large distance, electric field can be variable, okay? But for very small distance, electric field is what? It will be constant. You can understand it like this also. If, for example, we are charging this capacitor, so electric, again, I'm basically going to electromagnetic waves. There you will basically find that there will be the displacement current over here. Electric field will be variable. Changing electric field will create magnetic field, will create displacement current. Okay, see. Forget about this, whatever I'm trying to say. So electric field will be set up for a very large distance. If I say electric field is variable, if we decrease the distance for very small distance, it will be constant now. So that's why I'm saying that for this one, it will be constant. You will ask, sir, why do we need the constant electric field over here? I'll tell you the answer, okay? So this is the electric field will set up over here, this constant electric field from this point to this point. Now, if electric field is set up over here, means there is potential difference. There is difference in potential. Potential will be exactly there. See, this is the positive plate, this is the negative plate. We say this is at higher potential, this is at lower potential. Understand? Charge, this electron is moving from this plate to this plate, from one end to another end, from higher potential to lower potential. This is right now at higher potential, this end, this is right now at lower potential. When electric field is there, either you can understand it like this also. When electric field is there, potential will be there. You will say, sir, how? Give me the proof. Give me the proof. Have you studied the relation? I have told you this in the Gauss law. In this Gauss law, I told you the relation between electric field and this potential. What was that? That relation was exactly electric field is nothing but minus dV by dr. This was the relation between electric field and this. Means if at a point in space, if you know the potential over here, that is V, and if you want to find the electric field, you need to differentiate that electric field with respect to this R. So that will give you the electric field at this point. Or if electric field is given, if you want to find the potential at this point, what you are supposed to do, reverse process this, take it over there. So dV is nothing but minus E dot this dr, exactly. So integrate this one, that will be delta V is nothing but integration of E dr. So if you know the electric field at this point, you can find the potential. Understand? This is the relation between this and this. So according to this, electric field is over here, there will be potential. You can use this concept also. There will be potential. This is at higher potential, this is at lower potential, there will be potential difference. This delta V is what? Potential difference. Integrate this electric field. If this is constant, take it out. So that's why I'm saying now one more point over here is, if I make you understand that, you getting the point what I'm trying to say? Is it lagging? Is it lagging? So we say this is the relation between electric field and this potential clearly over here. So from this point to this point exactly. Understand? So this is how we can exactly define the potential between this point and this point. This is at higher potential, this is at lower potential. Electric field is set up between this and this. Okay, that's great. So this is the golden relation. You need to basically remember this one. You will love it. This is a nice relation. dV, this dr, exactly. Okay, let's now get the capacitance of this one. I forgot. I had to tell you something more. I forgot that exactly. What was that? Okay. Chalo. So we got this relation right now over here. Integration dV by dr, exactly. Fine. Now the next thing is, we need to find the capacitance of this polar plate capacitor. Understand? It will have capacitance because we have stored the charge over here. Electric field is charges. This electrical energy is stored in the form of what? Electric field. Understand? Because between this and this is electric field. That's why in capacitor we say electrical energy is stored in the form of electric field. Understand? So what is storing this electric field over here, or what is creating this? That is this battery. This external battery is doing work done, that is stored. That I'll tell you after some time. That is basically storing this electric field in the form of electrical energy. Now in this case, can you tell me how much is the capacitance over here? Now it is very simple. You will say, in this case, how much is the capacitance? Capacitance is nothing but C is equal to, that is this Q by this V. Now, how much is the potential difference over here? Can you find the potential difference over here? It is very simple. By using this formula only, the electric field is set up. Potential difference will be there from this point to this point exactly. This is at higher potential, lower potential. Charge move from this point to this point exactly. Now, you tell me one thing. Can you find this by using this formula? So you'll say this dV is nothing but, use this one. This dV is nothing but E dr. Forget about this negative sign. We are finding the magnitude only. Okay. So how much, if I say this potential will be how much? If I say this is V, okay? For example, potential difference from this point to this point, dV is, if I say, for example, that is V. And this electric field is also constant. And what is the distance between this and this? Can I say this dr is, RD is very small. So this is nothing but D exactly. Now, the point over here is, how much is the electric field? How much is the electric field in this case between this and this? How we can exactly calculate this one? You might have studied this in your Gauss law as well. That is, अरे यार जगह ही नहीं छोड़ा है. 1 second, I'll just create one more slide over here. Okay. This space. I'll just delete this 1 second, guys. Okay. So this one, electric field. Okay, fine. Now let me just tell you electric field. When we were basically studying the Gauss law, in that case we studied, for example, this is a charged sheet, okay? This is a charged sheet. Because of this charged sheet at a point P, how much will be the electric field? Then you make that Gaussian cylinder, okay? Something like this. And it was coming out to be, because of this sheet, it was coming out to be, that is what? That is sigma by, this electric field was coming out to be, that is sigma by what? That is 2 epsilon naught. Understand? By using, we've basically found the electric flux through this one, then through this one, through the curved surface area only. Integrate all of those, add those. Finally, we got the electric field, this one. Understand? Because of one sheet. Now over here, sigma by 2 epsilon naught. Over here, there are 2 sheets, okay? This first one, this second one. So can I say because of the other one, electric field will be also, that is nothing but, you'll say, sir, that on that is negative charge. Forget about that sign, okay? So that, because that's just giving you the direction. E is equal to nothing but sigma by 2 epsilon naught. Because of that one also, can I just say, because of the 2 sheets, it will be this plus this exactly. So E net between these two will be nothing but sigma by 2 epsilon naught plus sigma by 2 epsilon naught. Can I say this will be sigma by epsilon naught exactly between the plates? So we got the electric field. Put it over here. So this will be nothing but electric field between the plates is nothing but sigma by epsilon naught multiplied by this D. Now you tell me one thing. Over here, forget about this sigma. We know the charge. Previously, this was infinitely long. This was infinitely long sheet. That's why we take sigma, charge per unit area. But over here, we know how much is charge present, that is Q. So can you tell me this sigma over here? You'll say, sir, sigma is very simple. Sigma is nothing but charge per unit area. How much charge is over there? This charge, Q, on this entire sheet, if I talk about, that is Q upon area. If I say that is nothing but A, area A of this plate. Yeah, great. So can I just write it over here? This is nothing but sigma will be epsilon naught. It will be nothing but this sigma, instead of this sigma, that is this Q by this A epsilon naught multiplied by this D. So this came out to be the potential difference in this case. Now we know the relation, that is put this over here. So we'll get this exactly. So can we just write in this case, it will be this Q as it is, instead of this V, that is Q by A epsilon naught, and this will be D. So, okay, I'll just write it over here. It'll create the mess. Finally, it will be C is equal to Q by V. So it will be Q upon Q A by epsilon naught. It will be this Q A, अरे यार क्या लिख रहा हूँ? Q by A epsilon naught, one second. That is Q by A epsilon naught and multiplied by this D. So can I further write? It will be epsilon naught A by D exactly. So this capacitance is coming out to be epsilon naught, this A by D exactly. Fine. Got it? Everybody understood this one in the live chat? Okay, so this is basically what this is the capacitance of what? The polar plate capacitor. You tell me one thing, does this capacitance depend upon the charge placed on this capacitor? Definitely not. It depends upon the area. I told you dimensions. It depends upon the epsilon naught, medium, permittivity, distance between these two. It doesn't depend upon the charge or potential. That's why I told you this is a constant. This capacitance is constant. It depends upon the medium. Yes. Hi, dear Yawar, sir. Hello, what's up? Okay. Let's move on to the next one. Energy stored in this capacitor. Can you tell me how much will be the value and how we can exactly, how we are storing the energy in this case? Could you please tell me? I told you previously, if there is a charge over here, okay? This is a conductor, okay? Again and again, I'm taking the example of spherical conductor. This is a, if we, for example, there is some charge we have already stored. If we want to store more charge, so over here, it will repel this one in this direction, F electrostatic, understand? So if we want to store this one on that one, so we have to use the external force. So means our effort, we are storing the charge on this one. So our work done, this, we are bringing this charge nearer to this one, means we are doing some displacement also. Force multiplied by displacement, there is work done. That work done is being stored as that work done is being stored as energy on this one, understand? So that work done is being stored over there as energy. Now same is the case over here, but we don't have to do the work done, so battery has to do the work done. Battery is the external agent in this case, so we'll just connect the battery. So this is the battery, so this is the battery, okay? Positive, negative. So what initially is doing is that battery is initially doing that. Start the rotational motion also, okay? Potential I have done, okay? Earthing not yet. Potential is complete, everything. Okay? You watch that there is a playlist. There is mentioned in the thumbnail itself whatever the topic we are covering in a particular lecture, you can find it over there as well. Now see, listen to me very carefully. Initially this capacitor is not charged, understand? So finally we connected the battery. So what happens over there is it will extract this electrons from this one and shift will over there. So finally what happens on this plate, minus Q charge will occupy, on this plate plus Q charge will occupy. So means this battery is doing work done over here, external work done. It is extracting the electrons. So means the work done of this battery will be stored as electrical energy. You will say, sir, in the form of what? In the form of electric field. I told you, because this is basically taking the charge from this point to this point. That is setting up the electric field. So if this battery would not have done that, then that electric field would not have been created over here. So that's why I'm saying the work done of this battery is being stored as the energy over here. That is why I'm saying that work done will be stored as electrical energy. Now, can you find the value of that work done? Previously, if for example, this is a charge over here, okay? This is a charge over here. And this is, for example, the another charge at infinity. If I ask you to bring this charge from infinity to over here, you'll say, sir, yes, I can bring this. At this point, electrostatic force is repelling this one, and we need to use the external force in order to bring near this one. Our work done will be stored as energy. And what was the value of that energy? How did you basically define the potential energy as well over here? With respect to the potential energy, with respect to the potential difference as well. So have you studied this one, or forget about this one? Have you studied this one? For example, at this point, potential is what? A. At this point, potential is B. For example, VA, VB. What is the potential difference? You'll say work done in bringing the charge from this point to this point will be equal to, potential difference between this point to this point is equal to work done in bringing the charge from this point to this point divided by the value of that charge. We are bringing the charge from this point, or simply dq from this point to this point, storing over here. So means in that case, this is at higher potential, this is lower potential. Can you tell me the potential difference in that case? Previously, you have studied this VA minus VB is nothing but work done by external force divided by in bringing that charge. This was the definition of potential difference. What? If you want to take a charge from one point to another, understand? So the potential difference is defined as the work done in bringing that charge from B to A divided by that unit charge. Understand? That very small charge. Same, you are bringing the charge from this point, dq charge from this plate to this plate, from this point to this point, B to A to B, whatever it is. Understand? So over here, what will be the work done? Work done by the battery over here divided by how much charge you are taking. For example, dq charge divided by dq charge. And by taking the dq charge from here to here, the work done will be also very small, that is dw. You getting me? Yeah, that's what I'm explaining, okay? I'm just trying to give you the feel. So can I just write exactly over here? That is simply nothing but this. This delta V is nothing but how much amount of work are you doing? You are taking very small charge from this plate to this plate, small dq. Sir, you will say that is dq, sir. And how much amount of work you are doing? Very small. Sir, VA minus VB, delta V. Work done by external agent, that is battery over here. How much it is taking? dq from this plate to this plate. That is dq. How much work that will be? Very small work. So can I just write dw in that case? Any problem in this one? Yes, exactly. Any problem in this one? Any problem in this one? So this d, either you write delta V, dV, V, delta V by delta V, or simply you write potential difference between this and this is V. VA minus VB is coming out to be V. Just make sure you understand the concept behind this. Whatever the concept is, understand. Baki rest, these equations will basically, you can mention whatever you like, okay? So that the field should be there, exactly. So now, in this case, can you please tell me, can I just write from this one, dW is nothing but this will be V dQ exactly, 100%. Now, this is the small work done in bringing this charge from this point to this point, understand? Previously, I also made you understand this one. Now, if potential is increased from this point to this point, so work done, we need to do more amount of work done in extracting the charge from this point to this point, like that. If potential is increased, if we store more charge at this point, we need to do more amount of work done in taking the charge and storing on that capacitor. That is the explanation of this one. So this is the small work done. If you want to find the total work done, you will say, sir, integration of this dW give me the total work done is nothing but this integration of V dQ exactly. Can you tell me this potential in case of the polar plate capacitor? We have studied this. That is, this C is equal to Q by V exactly. Take it over there. This V will be nothing but Q by C exactly. Just put it over here. So integration of dW, this is the total. That will give you the total work done. I'll just write that total work done is nothing but this integration of that is 1 by C Q dQ exactly. Take this out. So W is equal to 1 by C integration of this Q dQ exactly. You are storing the charge, okay? So W is equal to 1 by C. This is constant. Capacitance is constant. So it will be nothing but Q square by 2. So it will be nothing but W is equal to 1 by 2 or simply Q square by 2C exactly. So this is the work done. As I told you, this work done by the battery will be stored as the energy. So can I just write this is equal to U is equal to that is Q square by 2. So if we have stored the Q, if I say, for example, this is in terms of this Q, so we'll definitely write this Q. From 0 to Q, you just write over here, okay? Just this Q, so it will be nothing but, so U is nothing but Q square by 2C. Got it? You got the feel of this one? Is this crystal clear? How exactly? See, it is not only just putting up the equations over here, getting the result. Everybody can do that. But what is the concept behind these equations? What we are doing exactly? How energy is being stored? How potential is being created over there? Everything, that is what is mandatory. Then only you would be able to solve the problems of JEE Advanced. Understand? Otherwise, this derivation, this 8th class student can also do this. Main thing is behind this, how you can understand the concept. Okay, all of you like the video? That's mandatory. Mark the attendance. Okay, that's great. Combination of capacitor, series combination, this. Series combination, first of all, means previously we talked about there is a capacitor. We calculated its capacitance, that's okay. Now if I say I have 2-3 capacitors, I have connected them in series, okay? What will be the net capacitance, equivalent capacitance? Can you find that in this case? And do let me know in the live chat, is the potential same over here in all the 3 capacitors or a different? Is the potential same or a different? In the live chat, all of you. Will the potential be same in this case, series combination of capacitors or a different? And what about the charge? Will the charge be same or different? First tell me about the potential. Potential across all the three capacitors. Will it be same or different? Yes, it will be different, exactly. Now you will say why? See, if I say, for example, we connected this battery over here. So this battery is doing what? Extracting the charge from over here and taking it over there, and that is shifting. So if we're taking, for example, 10 coulomb of charge from this one, so we'll keep on shifting that 10 coulomb because this is in series. Understand? That will shift, that will shift, that will shift. Understand? Now the point over here is what happens to the potential. So this capacitor is directly connected to this battery. This potential is not, this capacitor is not directly connected to this battery like this positive terminal of this battery. This is directly connected. That's why in all the three, potential will be different and the charge flow will be basically same. Charge is what? Over here is what? Current will be, that is flow of charge. Charge flow will be same exactly in this case. So can I say over here, if I say, for example, potential in this case will be V1, in this case V2 and V3, and net potential, can I just write V will be nothing but that is V1 plus this V2 plus this V3 exactly 100%. Now, you tell me one thing. Could you please tell me the capacitance through this one? Because we need to find the net capacitance, equivalent capacitance. Could you please, could you please tell me in this case, what will be the capacitance in this one, in this one, in this one? Say, sir, it is very simple. Capacitance in first one will be C1, is nothing but charge in C1, that is Q, this Q, by what is the potential? That is this V1, comma. What is in this one? You will say, sir, the C2 is nothing but that is Q by V2. What is in C3, sir? This is nothing but Q by V3 exactly. Fine. Now we need to find the equivalent capacitance. Either you just add all of these because we need to find in terms of C only. So replace this with this one. So V will come out to be Q by C1 in this case. Can I say this V1 will be nothing but Q by C1? And this C2 will be nothing but Q by V2. This C3 will be nothing but that is Q by C3. V3 will be nothing but Q by C3. Now put this over here. Can we just find this V is what? C. This is the net. So in that case, can I say it will be nothing but Q charge, because Q is through all these. Q is through all these. So can I say Q upon C equivalent? Understand why C equivalent? Because net capacitance, equivalent capacitance, this is V. So it will be nothing but, what is this? Instead of this V1, we'll just put this Q by C1 plus Q by C2 plus Q by C3 exactly. Can we just finally write it? It will be this will cancel. So 1 by CEQ will come out to be, that is 1 by C1 plus 1 by C2 plus 1 by C3, and whatever it is, how many are there, you will keep on adding. So this is the equivalent capacitance in this case. Fine. Okay. Very simple. Might have studied this resistors, resistances in your 9th, 10th class. So this was the series combination, what happens in the series combination with the capacitances. Now, for example, if we have two capacitors only, if for example, I say there are two capacitors only, in that case, what you are supposed to do is, how can you find the equivalent capacitance C1, C2? So over here, you will simply say, sir, 1 by C equivalent will be nothing but 1 by this C1 plus 1 by C2. Further, it will be C1 plus C2 when we cross multiply this, and it will be 1 C1 into C2. So then we'll write C1, C2 by, or I'll just write it over here. So this I can write C equivalent will be nothing but take it over there, C1, C2 upon C1 plus C2 exactly. Fine. Now, if the two capacitors are exactly equal, means C1 is equal to C2 is equal to C. In that case, these are the questions. By using these, you can exactly solve the questions. How will you find the C equivalent? So just take this one. So you can simply say this C equivalent will be nothing but C into C, C multiplied by C into C plus C. Because this what? C1 into C2, C1 plus C2. So simply it will be nothing but C square by 2C. So this will cancel, C by 2. So clearly capacitance decreases over here in case of this series. Understand? Now can you tell me the energy stored in series combination over here? It is very simple, just a 2-second process. Everybody understanding this one? Okay, let's find the energy stored in this combination now. You will say, sir, energy stored in one capacitor is nothing but Q square by 2C. Understand? Energy stored in three capacitors will be energy stored in first capacitor plus energy stored in second capacitor plus energy stored in third capacitor. Understand? So that is what we can exactly say over here. Now you tell me one thing. If I talk about there are three capacitors over here in this series combination, this one, this one, this one. If I say energy stored in this one will be U1. In all the three will be U total. So in this will be U2, in this will be U3. Can you find this U1, U2, U3? You will add all of these. That will be the net capacity. That will be the net energy stored in this one. So you will say, sir, it is very simple. For capacitor U1, because we know energy stored in a capacitor is nothing but we already, did we derive that? Yes, we already, where is that? Yeah, Q square by 2C exactly. Okay, so I'll just tell you two more forms of this one also. So Q, this is exactly, just remember this, U is equal to Q square by 2C exactly. So this is what? This is the energy stored in a capacitor. In a capacitor, energy stored. Fine. So everybody understanding this? Come on. Yeah, good evening, good evening. Everybody in the live chat, I just need to know. If I say this is what in terms of Q and C. Now if I ask you, you just write this in terms of Q and V exactly. Can you just write it? You will simply say it is very easy. Sir, C is equal to Q by V. Q and V. C is equal to Q by V. You will say this U will come out to be, that is Q by 2 into Q by V. This is Q square. This and this will cancel. So it will come out to be, that is 1 by 2 QV exactly. This is in terms of Q and V. If you want to write this expression, energy stored in a capacitor in terms of Q and V, this is 1 by 2 QV. You can also write it basically like this. Now, I'll just write over here, I'll just write over here in terms of Q and V, C and V, I guess. Yeah, C and V. Understand? C and V in terms of C and V. How can you exactly write? You will say simply, sir, it is nothing but Q is equal to CV in that case. So we say Q is equal to CV. Just put it over here. U is equal to Q square by 2C. So U will come out to be, what is the value of Q square? That is C square V square upon 2C. This will cancel. So it will be 1 by 2 CV square. Understand? 1 by 2 CV square. There are three formulas. In terms of Q and V, 1 by 2 CV. In terms of C and V, 1 by 2 CV square. In terms of Q and C, that is Q square by 2C. Just remember all these formulas. It will basically help us. Now, energy stored in this capacitor. Use the first formula. That is Q square by 2C in this case. Now you will say, sir, energy total in all the three capacitors in this series combination will be energy stored in first, energy stored in second, energy stored in third. So that will be nothing but U total, I'll just write, is nothing but U1 plus U2 plus U3. Can I just write it like that? Yes, exactly. Energy stored in first capacitor, that is Q square by 2C1, because capacitor is C1. That is Q square by, because charge is same in all the three capacitors in series, charge is same. That's why I'm writing Q only. Q square by 2C1 plus Q square by 2C2 plus Q square by 2C3. Q square by 2C3. This is nothing but U. This is nothing but U total. Fine. Q square by 2C1, this. Now from this expression, can you basically take this Q square by 2 common? So U total will come out to be, that is nothing but this Q square by 2, and it will be 1 by C1 plus 1 by C2 plus 1 by C3 exactly. Finally, you can write from this one, that is Q square by 2. 1 by C1, what can we write exactly? This one, 1 by C equivalent exactly. So U total in case of In case of series combination, how much it will be? You will simply say, sir, this is nothing but q square by 2c. 2c. Just let me C equivalent. Understand? So this will be the expression. Everybody got the feel? Come on. Can you find the individual voltages over here? Like I told you, this potential over here will be different, V1, V2, V3. If I ask you to find these V1, V2, V3, can you find this one? It's a very good question, okay? It's a very good question. Come on. In the live chat itself, yes, let me just finish. This is the first lecture. Let me just finish this one. I'll come up with a previous year question series on this one, okay? Yeah. Can you just find this one? Find the individual, not Q by C. Come on. In case of series, I'm asking. In case of this series combination. So we know over here that is V is equal to V1 plus V2 plus V3 exactly. Fine. So can I just write V is nothing but V1? If I ask you to tell me the V1 in this case, you will say, sir, that is Q by C1. So you will say, sir, that is nothing but this Q by C1 exactly plus Q by C2 exactly plus Q by C3 exactly. Understanding this one properly? Come on, in the live chat. I just want to know. All of you. Yes, Q will be same. Exactly. Can I just do one thing in this case? So V is equal to, if I take this Q common, 1 by C1 plus 1 by C2 plus 1 by C3 exactly, I can just write it over here. So now, if I want to find this Q, take this Q over there and put it over here. So what exactly I'll get? So Q will be nothing but, see, if I just want to find this Q and this will go and divide in this one. Then if we then cross multiply this with this one, finally what we'll exactly get, we'll get that is nothing but this C1, C2, C3 exactly. And in the denominator, we'll get C1, C2 plus C2, C3 plus C3, C1 exactly. You do this step by yourself because it's gonna take a bit of our time. So now over here, we need to basically do the final process. We are trying to find the V1, V2 and V3. On this, I'll be showing you the questions later also. Understand? Now you tell me one thing in this case. Do you know what is the value? What we are supposed to find, that is V1. So can you just tell me this V1 will be nothing but Q by C1 exactly. Now, so this V1, I can just write what is the value of Q that we recently got. That is nothing but this one only. That is nothing but this one only. So can I just write this V as it is, and it will be V by this. Instead of this Q, I'm just putting this. So V by, and this will be C1 as it is. So it will be nothing but C1, C2, C3 upon C1, C2 plus C2, C3 plus C3, C1 exactly. Remember this trick, okay? It will help you in solving the problems. So finally, I can just write it over here. This and this I can cancel. So finally, what I'm supposed to write over here is V1 is nothing but V into C, V into C2 and C3, V into C2, C3 upon this one, C1, C2, C1, C2 plus C2, C3 plus C3, C1 exactly. So this is how you can exactly find the potential individually. Understand? Now, the next thing is, similarly, you can find the potential that is V2. So if you find the V2, that is V2 will be V by C2. In that case, this C2 and this C2 will cancel. So remaining will be V into C1, C3 and this term. Simply, I can just write V into C1, C3 upon C1, C2 plus C2, C3 plus C3, C1 exactly. And I can definitely get the V3 also. That will be nothing but V into C1, C2 upon this C1, C2 plus C2, C3 plus C3, C1 exactly. You can definitely keep it in the box. Fine. So this is how we get exactly the individual potentials. Now we have the question on screen. I want all of you to tell me the answer of this question in the live chat itself. All of you, solve it as soon as possible. Come on. Can you solve it? In the live chat itself. First of all, two uncharged capacitors are connected in series with battery this much. With a battery of this one, find out the charge flowing through the battery. Understand? After they are connected, tell me. Can you just tell me the answer of this question? Charge flowing through the battery. What will be that? How much will be the charge flowing? Understand? You will simply say, sir, thus Q is nothing but C. What? C equivalent into V. Q is equal to CV. Understand? In case of series combination we are talking about, through this battery means Q is equal to C into V. C into V. That is C equivalent into V. C equivalent into V. Just tell me in the live chat what it will, how much it will be. So first of all, you need to basically find the C equivalent. How much that will be? You'll simply say, sir, the C equivalent will be nothing but, in case of this one, this is in series. So I just have to write this exactly. I just have to write this. C equivalent will be exactly 1 by C equivalent. That is 1 by this C1 plus 1 by this C2 plus 1 by this C3 exactly. So it will be 1 by 2 plus 1 by 3, 1 plus 1 by 6. It will come out to be, C equivalent will eventually come out to be 1 only. Okay, fine. Now put this over here. How much will be this charge? You will say, sir, this charge will be 1 multiplied by this is 30 is equal to 30 microcoulomb only. Fine. So you got it? How we can exactly solve this one? Now we have this potential energy through 3 microfarad capacitor. Through this capacitor, how much energy is stored in this capacitor? Come on, Q square by 2C, where you need to place the C as 3 only. So can I just write potential energy, second part, it will be nothing but stored energy. Stored will be that is nothing but Q square by 2C exactly. How much is the energy stored? How much is the charge over there? Understand? Q square by 2C exactly in this case. Yeah, what we need to find exactly? This one only. Yeah, okay, come on, tell me in this case how much exactly charge we got. Charge we previously got, that is how much? 30 microcoulomb. So 30 will be along through this, because in case of series combination, charge flow will same. Charge flow is same. So over through this, it will be 30 only. So it will be nothing but 30 square, and this will be nothing but 2 into capacitance through this one, that is nothing but 2 into 3 exactly. Everybody able to understand this one? Come on in the live chat, all of you. Come on in the live chat, all of you. Everybody solo this one before I do it, huh? Come on. Come on, how much it will be? 150 microjoule. Next we have the third one, that is total energy. Total energy, that will be nothing but U is equal to Q square by 2 C equivalent. Understand? Through all the series combination, through equivalent. So that is nothing but 30 multiplied by 30 into 2 into 1 exactly. Come on, this is nothing but 900 by 2, it is 450. This one exactly. Fine. Yeah, that's great. Moving on to the polar combination. Let's go for this polar combination now. If we have basically, previously, we have the 3 capacitors or more than 3 capacitors connected in series. We were supposed to find the what? We were supposed to find the equivalent capacitance in that case. Now, if I ask you, we have the 3 capacitors connected in parallel. In that case, I am asking you to tell me the equivalent capacitance, potential energy stored in this parallel combination, and individual charges also. Understand? Can you tell me charge through this one, charge through this one? Now, you just tell me one thing. See, over here, the potential will be same, but the charge will be different. Keep this thing in your mind. Potential will be same, the charge will be different. So if I say, for example, this battery is extracting the charge from all of these and sending to this one. Understand? Or it is extracting the charge from here and transferring it to over here. So when it basically reaches over there, it will be distributed. Understand? So means this will receive some charge, this will receive some charge, this will receive some charge. So that's why over here charge is Q1, over here charge is Q2, over here charge is Q3. So means this charge is basically different through all these capacitors. And what about the potential? If I say over here the potential A, this is B. Now see, this A is connected. Now see, this A is connected to this also, this A is connected to this also directly, this A is connected to C3 also directly. Means potential through this, potential through this, potential through this will be exactly same. So in case of this combination, potential is same, but charge stored will be different. Charge stored will be different. Keep those things in your mind. Understand? Now listen to me very carefully. If I want to find the net capacitance in this case, how can I exactly find? Very simple. So can I just write this Q net charge will be nothing but charge stored in first Q1 plus Q2 plus Q3 exactly. Is there any problem in writing this one? There is no problem. Now this Q, can I just write? See, if I, okay, now tell me the capacitance through this C1. You will say, sir, this capacitance will be C1 is nothing but that is Q. Q is same, Q by potential through this V1, that is V1. So then C2 is nothing but Q by this V2. Fine. Then tell me C3 is nothing but that is Q by this V3. Okay, fine. Why is Q? Okay, Q is different. Sorry, Q1, Q2, Q3. And this is same. Potential is same. Potential is same. Fine. Yeah, exactly. Now, can you tell me in this case charge, because we'll put that value in this one and we'll get the equivalent capacitance. So in this case, can you just tell me this Q1 will be nothing but C1 into V. This Q2 is nothing but C2 into V. This Q3 is nothing but C3 into V. 100% I can just write it. Now just put it over here. Instead of this Q net charge, I can just write that is C equivalent into this V, because this V is same, is equal. In this one Q1, that is C1 into V plus C2 into V plus C3 into V instead of these. Now, can I just write from this V will cancel. C equivalent will come out to be C1 plus this C2 plus this C3 exactly. So what happens with the equivalent capacitance over here? It will basically add up. It will add up C1 plus C2 plus C3. So this is the equivalent capacitance in this case. Everybody understanding? Got it? Come on. So simply, if I say, for example, these are the three capacitors connected in parallel. So its equivalent capacitance will be what? You will simply say, sir, that C EQ will be nothing but C1 plus C2 plus C3 exactly. This is the case that we need to basically. Now energy is stored in this parallel combination. How can we exactly find? So there are three. There are exactly what? There are three capacitors connected in parallel. So we say energy stored in first capacitor plus energy stored in second capacitor plus energy stored in third capacitor. Fine, we can. Now we know the formula for energy. If there is a capacitor, we say energy stored in that capacitor is also 1 by 2 CV square. It is also 1 by U is equal to Q square by 2C also. In terms of C and V, we are writing that is nothing but 1 by 2 CV square. Fine, we know this one. Now, can I say energy energy stored in this one plus energy stored in this one plus energy stored in this one? So I'll just U1, U2, U3. Let's see what happens with the energy. What will be the expression in case of this energy? You will say, sir, this U total is nothing but that is what? U1 plus U2 plus U3 exactly. How much is U1? Simply, it is nothing but, U1 is nothing but 1 by 2. What is this C in case of U1? In case of this capacitor, capacitance is C1. So I'll just write this is C1 into V square. Potential is same in case of parallel combination. That's why I'm writing potential same. Plus 1 by 2 C2, this is V square, plus 1 by 2 C3 V square. Understand? In case of parallel combination, we take the potential same. So can you just tell me this U total will come out to be nothing but this will be 1 by 2 V square we take common. This will be 1 C1 C2 plus C3 in this case. Now you just tell me one thing. Everybody able to understand? Come on. So can I just write this? U total will be nothing but 1 by 2 V square. Instead of this C1, C2, C3, can I just write C equivalent? Because in case of Parallel combination C equivalent is C1, C2, C3. 100%. I can definitely write it C equivalent over here. So this U will be in case of what? Parallel combination 1 by 2 C equivalent into this V square. Just put it over here in the box. Got it? So this is this. Can you find the individual charge in parallel combination? Like I told you how to find the individual potential in parallel combination. Yes. There is no difficulty in finding that. We can exactly find this. We got no scenes. Fine. Now see, the question is, in case of parallel combination, charge stored over here is different. That's Q1. Over here, that is Q2. Over here, that is Q3. If I ask you to tell me how much is this Q3, Q1, Q2, how can you exactly find that? Let me just tell you. See, can I say the net charge is nothing but that is Q1 plus this Q2 plus this Q3, 100%. Now, we know in case of capacitors, that is Q is equal to what? CV. In case of this charge Q1, in case of this capacitor C1, so Q is equal to, can I just write it is C1 into V1, C1 into potential is same, sorry, not V1 into V, plus C2 into V plus C3 into V exactly. Now take this V common, so we can write it V into C1 plus C2 plus C3 exactly. Now if you want to find this potential over here, so what you will exactly do, take this over there, so it will be nothing but Q upon this C1 plus C2 plus C3 exactly. Fine. Now you just tell me one thing. You are supposed to find the charge Q1, individual charges. So I'll just write Q1 is nothing but C1 into this V, 100%, because we know this V. So put it over here. Q1, we are supposed to find this Q1 only. That is nothing but C1 into this V. So can I just write Q1 is nothing but C1. Instead of this V, we'll just put this one. So that is Q by C1 plus C2 plus C3 exactly. Now you just tell me what can I exactly write from here. This Q1 will come out to be that is QC1 by C1 plus C2 plus C3. Now afterwards, this is the charge Q1. So similarly, we can find the charge Q2. So in that case, instead of this C1 over here, it will be C2. So we can simply write C Q2, okay, Q2. Q2 is nothing but QC2 by C1 plus C2 plus C3. Similarly, Q3 will be nothing but QC3 upon C1 plus C2 plus C3. Fine, done. Now we have these two questions. Once we get done with this one, we are done with the lecture. Come on. Three initial charges, this. Okay, find the charge. This is a given system over here. Okay, parallel combination, you need to tell me the charge flowing through the circuit, through this one, battery. Total charge stored, total energy stored, okay. Total energy stored, potential energy stored in 3 microfarad. Exactly, you are supposed to tell me this one over here. Now, come on. It's very simple. Can you just solve it by yourself? I just want to know in the live chat. So simple. First of all, Q is equal to C equivalent into V. Fine. Can I just write it exactly like that? Now, how much is the charge through this battery? You will say, sir, it is very simple. C equivalent in this case, in case of parallel, C equivalent will be this plus this plus this. So 3, 2, 5, it will be 6 multiplied by this 10. So it will be nothing but 60. ये हो गया ऐसे. Fine, done. So what we need to exactly find in the second case, that is total energy stored in the capacitor. In the capacitor, how much that will be? So we can say U is equal to 1 by 2 CV square. So now this will be C equivalent exactly. Can I just write it like that? So it will be 1 by 2 multiplied by 6. Multiplied by 6. This is 6 basically, yeah, 6. And this will be multiplied by 10 into 10 exactly. Fine. Everybody able to understand this one? Come on. All of you, I just need to know in the live chat itself. Fine. You getting me what I'm trying to say? So this is the energy stored in this one. This is 600. This is 100. 600 by 2. It will come out to be 300. Okay. What is this energy? Microjoule, exactly. So energy stored in this capacitor, you will say simply 1 by 2 C3 V square, because potential is same in case of the polar combination. 1 by 2 multiplied by, that is 3 multiplied by 10 into this 10, exactly, because this V square is 10, this V is 10. So can I just write, this will be 300 by 2, so it will be 150 microjoules, exactly. So let's move on to the next question. Come on, clear? Yes, that's great. Now, two capacitors, this one are connected in series. This is the battery. Okay, positive, negative. The equivalent capacitance in this case is, how much will be the equivalent capacitance in this case? It's very simple. They are connected in series. In case of series, how do we find equivalent capacitance? That is nothing but 1 by C1 plus 1 by C2, exactly. This is 1 by C1 plus 1 by C2. So 1 by C equivalent is nothing but, can I just write 1 by C1? Kitna hai ye? 1 by 6 plus 1 by 3. So it will be nothing but 6. If you reciprocate, what do we say, that C equivalent will come out to be 6 into 3 by 6 plus 3. It is, this is 18 by 9. That is 2 microfarad capacitance. Okay. Then we have potential difference across each capacitor. How can you find the potential difference across each capacitor? I told you previously, in case of series combination, this is how can you exactly find the potential difference across each capacitor, V1, V2, V3, because in case of series combination, potential is a different across each capacitor. This is having potential V1, V2, V3. So if you have two capacitors only, we solved it for three capacitors, V1, V2, V3. If you have two capacitors only, in that case, this won't be the formula. You have to solve for two capacitors. The formula will be something like this only. One second. You getting me what I'm trying to say? Okay. Okay, this one. You getting me, everybody in the live chat, whatever the concepts are? All of you. So in this case, it will be nothing but V1 is nothing but C2 upon C1 plus C2 multiplied by that V, exactly. Fine. So this will be the individual potential in that case. So remember this, how you can derive this, I have told you previously. You just do it according to that only. So I'm not gonna derive this once again. So now just put the values over here. So V1 will be nothing but, what is the value of capacitance C2? What is the value of capacitance C2? That is, C2 is 3. This will be 3 by 6 plus 3 multiplied by this 18, I guess. This will be 18. This is 3. This will be 9. And it will exactly come out to be 6 volts. Okay. Yes. 6 volts. Now you are supposed to find V2. V2, either you can find this one only. That is C1. Over here, it will be C1 upon C1 plus C2 multiplied by V. Or you can directly find this net, V net. In case of series, it is nothing but V1 plus V2. So now you want to find what? V2. So you'll say V2 is nothing but V minus V1. So V2 is nothing but V is how much? Net is given, that is 18. So 18 minus this 6, it will be nothing but 12 volts. Fine. What else do we need to find? The charge on each capacitor. Come on. Charge on each capacitor. This is in series. Come on. Q is equal to CV. In case of the capacitor in series, the charge is same, because this charge is Q on this one. Over here, charge will be Q. So can I just say third part will be nothing but, that is Q1 is equal to Q2 is equal to Q. So in that case, Q is equal to CV, exactly. Put the value and get the answer. Fine. Yo, this was all about today, ladies and gentlemen. Thank you so much. It was nice interacting with you. I hope you liked the video. Everybody of you, before leaving, I want you to like this video as soon as possible. Okay. And Apart from this YouTube platform, we teach on Unacademy's own platform. Okay, Unacademy. Let's crack it. So in Unacademy, we have this. You can take this plus subscription because country's top educators teach you over there. Over there, you will be having live classes, weekly tests, structured courses, unlimited access. Understand? And apart from this, if you take this Iconic subscription, you'll be getting all the benefits you get in Plus. Ria, you understood everything in today's lecture? Any sort of confusion anywhere? Or everything is crystal clear? So apart from this, in Iconic subscription, you get the personal guidance, test analysis, experts guidelines, study material, study planners. Okay? Yeah. Okay. So what happens in this unlimited access means you can watch anybody's lecture. If you take the IIT JEE category plus subscription, over there, if there are 100 educators who are teaching you. Yeah. Okay. Fine. And what about the problems? You didn't understand that? And in this Iconic subscription, you'll be getting the personal guidance, test analysis, and personal guidance is you'll be getting an educator. Yes, that's great. You'll be getting an educator that will help you throughout your exam in cracking. And if you want to follow me, you can definitely follow me on Unacademy. This is my username. Okay. You want to follow me? This is my username on Unacademy. And this is the set test that is gonna happen on 12th. So I suggest you to enroll in this one, because if you get the rank under 1000, you'll be getting 100% scholarship. So use my code so I suggest you to go for this one. Okay, use my code Yawar while you enroll. And these are the batches which we have launched recently on Unacademy. And this batch, Shine batch, is completely in English language. You should definitely go for this Shine batch. Okay, because this is for JEE Mains and Advanced 2022, definitely. Fine. And you can take this plus subscription for like 3 months, 6 months, 12 months, 18 months, and 24 months. Like, there are EMI options available as well. If you don't have to pay the entire amount at once, okay, you can use my code in order to get the maximum possible discount. Okay, this is my code. Can use this one in order to get the maximum possible discount for sure. And if you take this Iconic subscription for 12 months, for 18 months, and for 24 months, the prices are mentioned over here. The prices are mentioned. By using my code Yawar, you can get the maximum possible discount for sure. Okay. Yes. I'm planning to basically okay, ladies and gentlemen, let me basically reveal it over here only. I'll come up with the special classes from tomorrow, I guess, onwards. We'll be solving the previous year questions only. Okay, from starting to the ending, understand, to end. So I'll be completing all the previous year questions, whatever have come till today in JEE Physics. And if you have, this is Ask a Doubt feature on Unacademy. If you have any sort of doubt, you can definitely ask. So this is, you can ask unlimited number of doubts. You can ask doubt anytime and you'll get the solutions, that too high quality solutions. And how you can exactly ask this doubt, we have this doubt solution option over there. You can click on this one. Then you need to take the picture of that doubt. Okay, you need to take the picture of that doubt, and that should be very clear, understand? And this, you need to crop that particular doubt and you'll get the solution for sure. And ladies and gentlemen, these are the things that you need to keep in your mind while you ask the doubt. Thank you so much. It was nice interacting with you people. It was great interacting with you people. And I suggest you to basically subscribe to this channel, JEE English Unacademy. Hit the bell notification. Like this video. Comment on this video. Okay. because that is mandatory. So I suggest you to definitely you should go for this one. So thank you so much, ladies and gentlemen. Bye bye. Take care. See you soon. Okay. Bye.